All right, guys. Thank you. Before we start copying down that example, I just want us to talk about what does optimization actually mean. Now, you'll see it's basically like, I almost want to say this because I don't want to put you guys off, but it's almost like a word problem in a sense. But you are going to identify this type of question by the word maximum or minimum. All right, they'll always ask for a minimum thing or something that will minimize the cost or something that will maximize the area. You'll see when you do some examples. All right, so what we're going to look for here is what are the words maximize or minimize. And obviously it's an application of calculus, so we are going to work with derivatives somewhere in this chapter. Right, now, in order to figure out what we're going to do every time, because we are going to have a similar method, we just need to quickly think back to a graph. All right, so let's just draw a very rough, or like a sketch graph of a little cubic graph there. Don't worry about having axes, it doesn't matter, just that shape. Now, hopefully you guys remember that, I'm just going to color here, this point here, that would be a turning point, right? Now that turning point, can anyone remember what we call that turning point? A local maximum, thank you. So this is local max turning point. And then at the other turning point, we have a local minimum. Do you guys remember that? Local min turning point. Now guys, if you have the equation of a function and you need to draw it, how do you find the coordinates of the turning point? What do you always do? First derivative equal to 0. Okay, so to get your turning points, the maximum and the minimum turning points, you have the same method, right? You're going to take the derivative of the function and you're going to make that equal to 0. And then solve for x. If your function has two turning points, how are you going to know which one is the maximum and which one is the minimum turning point? There are different methods, but I think the simplest one would be to sub the x values in with the y values, and then you can obviously see, right? The smaller y value would be a minimum one, and then the higher, the bigger y value would be the maximum one. All right, we're going to use the same method. Whenever we are going to find a maximum point or minimum point of any kind of function, you'll see now when we do an example, we're going to take the derivative of the function, make it equal to 0, and then based on the answers that we get, decide whether it's maximum or minimum. Okay, so that's just a little introduction. If you are still confused, don't stress. We're going to do examples now, and hopefully it will make sense. All right, so I would like you to copy that example down, please. You don't have to draw this graph or these graphs to any kind of scale. Just see, can you guys read that thing? Right, if I took a screenshot from the note so I can read it. If you can't read that up there, I'll tell you what they written. You know, if you need to read anything out there. Guys, that function there, the first one is x squared minus 6x plus 5. That's equal to x. Those two skew lines there, those are supposed to be parallel. Skew lines like that, all right, but this is saying M is parallel to the y-axis. And guys, when you're doing the graphs, don't stress about it having to be to scale. Just make sure that M and N are in line with each other. Right? Because that's what they're saying in the question. Really? No. There are different types of questions that they can ask for it as well. You could have done it in a different way. By finding, because MN is going to be a quadratic equation, and you can find the turning point of that. That's what it's doing. No, it doesn't have to be. Just make sure that M and N are in line. Yeah, that's very important. If you are done and you think you have an idea of how to do A, you can try that also on. If not, you can wait for another minute or so. Minute or so. Right, guys, just quickly, if we go through the information that was given, it is obviously quite important that we make sure that we know what's going on here. So they've given us some equations here. I'm actually just going to write that in. F of x, right? They told us that that is Oh, sorry, so is x squared, what was it, minus 6x plus 5, right? That's the equation of x. And then the equation of g was 4x plus 1. That's obviously a straight line equation there. 4x plus 1. Then they're telling us that m is a point on gx. Okay, we can see that. That's what it's clarifying. And n is a point on f of x such that n lies directly underneath m. So that means, guys, what will these 2 points have that are the same? The x coordinate will be the same, right? So these 2 points, and if you're looking at the actual picture that I have, it's fine, you don't need to be able to read it off there, but we can see that they do have the same x value, right? Like 2, something. Okay. So these 2 points, if they lie directly underneath each other, or n is directly underneath n, they do have the same x value. They will obviously have different y values, right? Point M, it looks like has quite a big y value there, and then point N has a negative y value. All right. Now, guys, they're asking for, they're also saying that MN, I think, is parallel to the y-axis. That's just another way of clarifying that these 2 points have the same x value. All right. Now, guys, they're asking us for an expression for the length of MN. Now, if we knew exactly what these 2 y values would be, what would we do to get the actual length? Not an expression, but the actual length. If I could read off very accurately what the y value of m is and the y value of n, what would I have to do with those 2 values to get the length? Just the y values. Okay, so we could use the distance formula, but guys, these 2 are in line, right? So we could just take the y value of n, the higher point, minus the y value of n, and that will give us the length of m. All right, and we did these calculations at the end of grade 10, I think was the first time we did it. All right, so the length of mn is actually going to be the y value of n minus the y value of n. Now, on my graph, I could kind of guess, right, what the values are, but I don't know specifically or accurately. So we need to use an expression for that. So for A, we're going to say MN is equal to the y value of M minus the y value of N. Please add that step in there. The y value of M minus the y value of N. Now, guys, we don't have the y values, right? But we have formulas to get the y value. We have an equation for f. Now, n lies on it, right? The point n lies on it. So to get the y value of n, I'm going to use that whole equation. Because, guys, isn't that how I would find the y value of any point on graph x? If I have the x value of that point, I can sub it into this equation, and this equation will give me the y value of that point. Right, so this equation is actually an expression for any y value on the graph. Same thing here. If I want to find the y value of m, if I know what the x value is, I can sub it into this equation, and this will give me the y value. Right, so the actual equations of the graphs, guys, are expressions for the y value. So what we're going to do is we're going to say what graph does m lie on again? M lies on the straight line. So we're going to do the equation of the straight line at the top. That's the higher value, the higher point, minus, to get an expression for the y value of point n, we take the equation that n is on. All right, so the equation of the graph. So that is, in brackets, please, very important, x squared minus 6x plus 5. Now we would just have to simplify that, please. So we have to multiply that minus into brackets and then add your like terms. So we have 4x plus 1 minus x squared plus 6x minus 5. And then we can just simplify that. So I'm just going to put the x squared term in front. It doesn't really matter. You don't have to. All right, so let's do minus x squared there. We have 4x plus 6x, that is 10x. And what else? Minus 4, right? 1 minus 5 is negative 4. So guys, this is an expression for the length of MN. Right? The y value of M minus the y value of M. Are you kind of okay with that? You are going to practice some of these on your own as well. But guys, this is quite a common final exam question as well. Okay, where they're giving you two functions, you have a point on the one and a point on the other one, they want the length. So you always take the equation of the higher point minus the equation of the lower one. Okay. Now for B, just quickly to read through the question again. Now they're asking for the maximum length of MN. So that is now where we are getting the whole maximum. Right? Determine the maximum length of MN. Now, I will talk about, and that's what I was saying to Connie earlier, I will talk about the kind of grade 11 method in which you could have done this, but let's use our knowledge of derivatives now because it is a bit easier to find this maximum length. Now, guys, for maximum, if we're just thinking of this expression now, what type of function would this be? This would be a parabola, right? Negative x squared plus 10x minus 4. What shape would this parabola have? If A is negative, it's going to be a sad face, right? The downward facing one. So it would look like this. If you had to actually sketch that as a function, right? The length of n, that function. Now, where would I find the maximum value of this function? At the turning point, all right? Now, in grade 11, we taught you a formula for finding the turning point of a parabola, which was negative b over 2a. You're more than welcome to do that, but guys, this formula only works for parabola. All right? What did we now learn before the exams? How can you find the turning point of any graph? Derivative equal to 0. Okay, so that's what we are going to do, guys, because that is what we are. Let's do mn dash to represent the derivative. This is the method that will work for all our questions. All right, this method will only work if you have a parabola function, a quadratic function there. So let's work with the derivative equal to 0. Okay. So this is what you do when you need to find the maximum or the minimum, but in this case, since our function is of this shape, we will only get the maximum. Okay. So the derivative of mn. Now guys, this is quite an easy derivative to get until you remember this. What is the derivative of negative x squared? Negative 2x. All right, the derivative of 10x is just 10, so that's plus 10. And then what is the derivative of a constant term? Always 0. Okay, so the derivative here is just that. And now this is very easy to solve. Negative 2x plus 10. I'm just going to move that 10 over to the other side. It's going to become negative 10. So x is going to be equal to 5. Okay, now what does that mean? Is that the maximum length of MN that I found? I found x equals 5. Let's just go back up to the picture. What does that mean, guys? That means that the x value for these 2 points is 5. All right? But what can we do here? We have an actual equation, a formula for the length of MN. Now, if I want to find the maximum length of MN, and I know that the maximum length is where x is equal to 5, can't I just sub that 5 in there? Right? And that will then give you the maximum length. So let's just write a little extra note here on the side, guys. Let's just say MN is at a maximum, if you want to write it out, where x is equal to 5. Therefore, sub x equals 5 into expression for n. Okay, so I'm just going to write here at the bottom, therefore, and I'm just going to write maximum MN will be equal to, now I'm using that equation up there, that expression that we got, negative x squared plus 10x minus 4. So that is going to be negative 5 squared plus 10 times 5 minus 4. Okay, so what's that? That's negative 25 plus 50 minus 4. That's 21, hey? 21 units. Now guys, what this actually means, I'm just going to go up to the picture again and then I'll move back down for those who got off that. What this means is, if you had to take any, no, it's not. When they ask me for the maximum length of MN, they didn't specify at the beginning of the question where M and N are. The only things they specified are that they're in line with each other. Right? So we can almost visualize this MN as if it can move. Right? It can be anywhere here between like those 2 points of intersection, if that makes sense. Okay, so they're asking us, where would MN be the longest? Where is the distance between the two graphs the biggest, the maximum length? Okay, so we are finding where in terms of x, so at x equals 5, and you can even see on the picture, that is not x equals 5. Right, you can see where they draw it. It kind of looks like, I almost feel like 5 would be over there. Right? So they didn't even draw it at x equals 5. So they're actually saying that over here, if we wanted to draw that line in there, right? If M was actually over there and N was there, that would be the maximum distance between those two graphs. Okay, would be 21 units. And that always looks more accurate because that in here is 0, and that kind of looks like it could be 4. Okay. All right, any questions on this, guys? I know it is tricky and it's a new concept, so let me know if you have any questions. We are going to do a different example now that is different, not using graphs, but also maximum minimum. Are there any questions on this at this point? Okay, let's do the next one. To the beginning. What this? Here we go. Now we're going to work with some surface areas and volumes and stuff. We haven't worked with that in a while. Although, did you do that? No. Did you guys? Never mind. Sorry, ignore me. Okay, so they are saying, I'm just trying to get the spacing correct here. A closed rectangular prism has a length of 10 minus x. Let's draw that in on the picture as well. A width of x and a height of 4. And now we also have the rotation thing. Okay, guys, can you remember how you find the total surface area of a rectangular prism? That's wrong. So yes, but not necessarily squares. Okay, if we look at so sorry, I'm responding to the answers here, but I don't think it's on Earth. How many faces does this shape have, guys? Six, right? So we need to find the areas of all six of those faces and add them together. But we can simplify it a bit because the front rectangle that we have here, what are the dimensions of the rectangle in front? 10 minus x and 4. All right, now guys, the rectangle in front and the rectangle at the back, they have the same dimensions, right? They are the same. So if we want to find the area of the front and the back rectangles, we can say 2 times 4 times 10 minus x. Right, does that make sense? So let's actually write that down as we are doing it. I'll do it here on the side. TSA, you are allowed to use that abbreviation for total surface area. So we're doing the front and the back rectangles. And guys, it doesn't matter which order you work in. All right, you can do the side rectangles or the top and bottom first. It really doesn't matter. So we're going to say 2 times 4 times 10 minus x. Right, those are the front and back rectangles. Plus, let's do top and bottom next. Again, the rectangle at the top and the bottom will be the same, so we can say 2 times. Now, what are the dimensions of the rectangles at the top and the bottom? It's easier to look at the bottom one because those dimensions are actually filled in, right? It's going to be 10 minus x multiplied by x, right? Those are the dimensions of the top and the bottom ones. I'm just going to put the x first because I prefer multiplying something into a bracket in that order, but it doesn't matter, really. And now the 2 rectangles on the side, again, they will be the same. So those ones, and the dimensions of those 2 rectangles are quite nice. It's just 4 times x. All right, so 2 times 4 times x. Now, guys, please, even though they don't say that to simplify it, okay, I can make the rest of this question easier for you. So let's quickly work that out. So we have 2 times 4, this is 8, right? Are you with me? And then I'm going to say 8 times 10 is 80. And 8 times negative x is negative 8x. Right? Are we fine with that? So that is that first term that I've now simplified. And I'm getting 80 minus 8x, and we can find it. Plus, if we're looking at the next one here, 2x is what I have in front, and I'm going to multiply that by 10. Are we okay with that being 20x? Right? And then 2x times negative x is negative 2x squared. Okay, last bit. This one is easy enough. 2 times 4 times x is 8x. And guys, what happens here is we have a negative 8x and a positive 8x. So I'm just going to cancel each other out. And then we can just write this kind of in order. You don't really have to, but I prefer having my x squared in front always. So it's going to be negative 2x squared. These 8x's cancel each other out, but I do still have the 20x there. And then I still have a positive 80. All right, so there we have an expression for the total surface area of that rectangular prism. Yes. Then you must just keep the 2 in front. So you can't divide it only if it's equal to 0. Can you do that? Okay. All right, now let's look at B. Let's try to get the bottom. Determine the length and breadth of the prism. Sorry, the length and breadth of the prism such that the total surface area will be a maximum. So now they're saying here that the total surface area has to be a maximum. Now guys, we have an expression for the total surface area, right? The total surface area is represented by this expression. And again, what type of expression is this? This is a quadratic, right? Again, this is a downward facing parabola. You have to actually graph that. So how do I find the maximum here? Derivative equal to 0. Okay, and guys, you can just remember that either they're asking for maximum or minimum. In this case, they can't ask for minimum. Right? Do we understand why? Why can they not ask for minimum? What is the minimum of that picture there that I've drawn? That parabola. Negative infinity. Hey. Right, so there isn't actually a minimum. Okay, so for B, let's say we're gonna take the TSA dash, write it like that, and we're gonna make that equal to 0. So whenever you see minimum or maximum, you're gonna write whatever your expression is, that function, the derivative of that equal to 0. Again, this is quite a nice derivative to find. The derivative of negative 2x squared is negative 4x. Do you agree with that? And then the derivative of 20x is plus 20. I'm going to move that 20 over, so I have negative 4x equal to negative 20. So what is x here? Again, 5, right? But guys, that is just x. What did they actually ask for in this question? Not x, just in B, they're asking for the length and breadth. Why are they not asking for the height, right? The height is 4. Okay, that one they've actually given first. So they want these two dimensions. They want the value of the length and then the value of the breadth as well. All right, so the length is 10 minus x. So therefore, the length is, I'm going to write 10 minus x here so that you remember where this is coming from. But now we know that x is 5. So what is that? 10 minus 5 is 5. If they tell us what this is, just, oh, centimeters. Yes. Okay, so the length is 5 centimeters. And the breadth was just x, which is then also 5. Okay, so I'm just going to write breadth is x, which is also 5. It doesn't really matter, no, but in the description of this question, it did say the length is 10 minus. Okay, but otherwise it wouldn't matter. All right, C, the last question. In C, they're now asking for the actual maximum total surface area. All right, so in B, they ask for the length and breadth that will give me a maximum surface area. And now in C, they're asking for the maximum surface area. So guys, just like what we did in the previous example, we have an expression for the surface area here. Yeah. Well, it's not because you have that 4 there. There's 5 and 5 and 4. But you can, all right? So guys, you could use your 5 and your 5 and your 4 and work the surface area out from scratch again. But we do have an expression for the surface area here, which we can also do. All right, so if I just sub in x equals 5 here, it will give me the maximum surface area. All right, so let me just not say therefore total surface weight. Maximum total surface area. Oh dear, I'm all over the place. My apologies. Maximum total surface area is going to be, I'm using that expression there. So negative 2 times 5 squared plus 20 times 5 plus 18. We calculated that we have a maximum surface area where x is 5, right? So if I sub in x equals 5, it will give me the surface area, yeah. Okay, do you know what this answer is? What? 130, thank you, sorry, I didn't say. 130 And now please, centimeters. It's in this question where they'll decide between the large the units. Okay, so you have to make sure that if you're working out area, you have to have the thing with weight. For this whole question, so you would let's see, let me use a little red one here. You would probably get 2 marks for solving and all of that stuff, and then a mark for that simplification. Here you would get 1, 2, so a mark for the derivative, a mark for equal to 0, and then a mark for x equals 5, and then probably 1 mark for both of those, the same value. And then for this, it will be 2 marks, 1 for subbing in, 1 for out. Yeah. Say again? Yes, yeah, that's that. All right, guys, so basically the common thread here is we need to find an expression for what they're asking us to maximize and minimize, right? But usually they do break the question up like this. Usually they say, find an expression for something. A. B is A. You have to make the derivative equal to zero. So I'm going to give you 2 questions that are very similar to these ones. And then tomorrow, once we mark them, we're going to do more complicated ones with like cutouts and all sorts of things. So exercise 9.4. On page 230. It starts on page 230, but the questions that I want you to do on numbers 5, and then on the next page, if you turn the page, 30. Oh, sorry, that's full screen. Now, guys, number 5 is about volume. It's also a rectangular prism, so it's the exact same shape as we just looked at. And they do give you the dimensions of the sides. But just a reminder that volume of a rectangular prism is length times breadth times height. Okay, so that is the formula that you're going to have to work with for that question. All right, not the area like we did now, please. All right, so number 5 and 13, please. You can get going. You have about, what's that, 30 minutes. You can possibly finish in that time, isn't it?